Wait, hi everyone.
Correct. So we have a couple of questions. One was answered both in your last slide as well as in the chat, which is the URL for your GPU API. So let me start. Are you planning on extending the GPU module for other GPUs and languages like the Intel GPUs and SQL? What's the sort of effort required? And
yes, so for Intel GPU, actually we have an OpenCL backend which allows you to run the GPU code on your Intel GPU. So, and for SQL, we are currently developing the SQL backend, and hopefully we can release it very soon. And so yeah, that's our current plan.
Great. Another question was whether your implementation can leverage streams for asynchrony.
Yeah, that's a good question. Actually, so far our API is pretty much blocking API, and there's no CUDA memcopy async or something like that. And but yeah, we're going to try to support the more asynchronous API, like a CUDA memcopy async with the CUDA stream. Yeah.
So another question is the current approach seems to create a special GPU array from regular chapel arrays. Have you considered writing a custom distribution for your GPU?
Yeah, this is also your good question. So yeah, I'm not sure this is the right answer, but so yeah, motivation was that to take the regular chapel array and create a GPU array instance on the GPU, and I guess that might increase the productivity and the portability, because maybe you already have chapel array A, and you just want to put it into the initializer of the GPU array, and maybe you can add just single line to construct a GPU array on GPU. So I know some of the first work try to create their custom distribution for GPU. I think some of the IPDPS paper from the David Padel group to try to create a custom distribution for that, and that might be another direction. But so far, yeah, I'd like to stick with a more regular way to minimize the modification to the original chapel code. Does that answer your question?
I think so. If not, we should follow up. I think so. Brad had a question. I think it was just a clarification. If you look at some of your slides where you showed the number of lines added, it seemed like the lines added for the low rows seemed to be smaller than mid-low. Why was that?
Sure. So can I share my screen? So yeah. I think so can I see the screen?
Yep, go ahead.
So but clarify, your question was that why mid to low level takes much longer line compared to low level?
Yes, that's right.
So yeah, so the thing is that actually, so okay, so one thing that for low level in this chunks case, we need to convert the original chapel data structure, because this is written in the pretty much object-oriented way. So there are a lot of the class dot something like that, and we need some conversion from the chapel object into the more GPU-friendly data structures, and that's why it takes some line. And with that, so we also need to get for example, in this mid to low level approach, we need to get a size of pointer, size of data using the C void pointer, something like that. And so it requires a lot of the more auxiliary code to invoke the malloc memcopy or something like that. That's why it takes a lot of line in the mid-low level. But as I mentioned earlier, so if you use the mid-level version, Yeah, so it actually abstracted away most of the C pointer type thing. So that's why we see there's some reduction in the source lines of code. Does that make sense?
Yeah, I see a thumbs up from Brad.
Thanks.
Right. So let's thank Akihiro again for a fascinating talk in terms of applying GPUs in Chapel.